So let's just play around with the idea of Newton's method before I give you the proper version. Okay, let's say you're asked to solve this here. So if you get a graph plotter and plot this, it will give you this. So what you're being asked is to find out a value of x here where this will equal this. Okay, so rather than trying to solve this here, we would translate this problem into this problem here. So by rather than solving this one here, we are going to try and solve this one here. Okay, so if you get a graph plotter and plot this, so when you're trying to use Newton's method, you won't be given a graph plotter. But at the moment, we are just playing around. We're just trying to investigate. So if you get a graph plotter and plot this, it will give you this. Okay, so you're trying to find out a value of x here where 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 the whole thing here equals 0. So that's this point here. Okay, so Newton's method here, you start out with your function here. This is our function here, and then you would guess an answer. So let's try and guess it as 1. So our first guess will be 1. So here the true answer is here, but let's pretend we didn't know that. So we would guess an answer near here. So we would guess, let's guess 1 here. So x0 equals 1. So remember, the idea here is that Newton's method is you guess your answer here. Okay, you would guess 1. So x0 equals 1, and then you would put it into the function here. You would put the number 1 into your function here. Then that would take you to this point here. Okay, so once you're at this point here, you can work out the gradient, because once you've got a function here, you can differentiate it to give you a gradient. Once you've got the gradient and you've got one particular point, then you can work out the equation of the tangent line that just touches this. So it will be something like this, and then that will give you once you've got your equation of a straight line, set the equation to be 0. So hang on, let's start again here. You start out with your function here, okay, and then you start out with your guess. You would then put your guess into it. You would put your guess into the original function here, okay. So that would then give you -1 here. Okay, so you put your guess into your original function here. That will give you -1. So what that means is you start out with your guess here, put it into the original function. You will jump to here. Okay, but you still need the so now you know the coordinates here. The coordinates here will be 1, comma -1, because you would put 1 into your original function. That equals -1. That's this -1 here. Now you need to know the gradient at this point. Okay, so hang on. So you start out with your function here, and then this is your guess. You put the guess into your original function. Now you know the coordinates. The coordinates here will be 1, -1. But then you need to know the gradient at that particular point. Well, the gradient, given your original function here, differentiate it. That will then give you your gradient. Okay, so this is your gradient. Now, so don't forget, you know the coordinates at this particular point here. So now you need to know the gradient at this particular point. So hang on. So now you need to put 1 into here. That will then give you your gradient at that particular point, which is here. Okay. So now you've got you've got the particular point and you've got the gradient. So this is a general form for the equation of a straight line. So here, hang on. So y0 here would be well, don't forget, our x equals 0. Our initial guess was 1, and then y0 is actually this thing here. Okay, it's -1. Okay, so looking at the diagram, this particular point here, the coordinates here will be 1, -1. This is really 0. This here is y 0. Okay, so so this is what you've got so far here. So now you can put this into here. You can put this into here, and then the gradient you know is 4, so you can put it into here. So once now you've got everything, you just need to rearrange it, blah blah blah, and this here is the equation of the tangent line. Okay, so if you get a graph plot and plot it, so we made the first guess here. We then jumped to this point here. Once we're at this point here, we can work out the gradient. Once we've got the gradient, then we can work out the equation of this tangent line here. Okay, so now now that you've got this equation here, you really want this point here. You see, this point here will be when you set this line here to be, when you set y to be 0. So set y to be 0. Set y to be 0. That will then, so you're originally here. Set y to be 0. So x equals 5 over 4. Okay, so that's your first your x1 there. So once you've got your equation here, okay, set this to be 0. Set y to be 0 here, and then but basically you want to find out this point here, and this point here is 5 over 4. Okay, and then in the next video we're going to start from here. So here, this point here is 5 over 4. So basically the next step is to use this as your second guess. So this will be your x1. So x1, you would jump, you will put it into the original function. That will then jump to here. Okay, so you're here. Straight up would be right at this point here. So now you would use this point to find out. Well, you would try and draw your tangent line right at this point here. So you need the gradient at that point. So eventually, well, I will continue in the next video. So this is our current stage here at the moment. 5 over 4. So this will be our next guess. Okay, I will continue in the next video.